Hello, today we're going to be talking about sign diagrams. So a sign diagram is going to allow us to see when a function is positive, meaning that it is above the x-axis, when a function is negative, meaning that it is below the x-axis, when it is either zero, meaning that your y value is zero, or if it's undefined, meaning that your y value does not have a value for a specific value of x. So if we look at the graphs below, as we can see here, if I look at the first graph here, I see certain features. So I see that my x-intercept is at -3. So on the number line, I put -3 there. Then I also see that my graph is above the x-axis here, and it's also above the x-axis here, which is why I have the positive signs written on the number line in green here. All right. If I look at the middle graph, I see that my x-intercepts are here at -2 and 4, which is on my number line here and here. And I can see that my graph is below the x-axis for x values that are less than -2 or smaller than -2. And it's also negative for any x values that are bigger than 4. So I have my negatives written on my number line here, and I see that it is above or positive between -2 and 4, which is why I have my green positive sign there. All right. And my third one I see here for this function, I see an x-intercept here at a +1, which I denoted on my number line. And I also see that there is a vertical asymptote here at 3, which is also noted here. I can see that my graph is positive or above the x-axis when x was less than 1, which is what I denoted here. And then I see that I was also positive when x was bigger than 3, which I denoted here. The function was negative or below the x-axis in between 1 and 3 here, which means that I put the negative sign here. All right, so that's just an introduction on looking at graphs and looking at sign diagrams. So the steps to success for drawing sign diagrams is that you first want to find the x-intercepts and vertical asymptotes. Once you have that, you're going to make a number line with that information on it. And then you're going to pick random numbers, a random number in each interval, and you're going to substitute it into the function. And then you're going to label the section of the sign graph depending on the sign of the output that you got in step 3. So for number 1, it says create a sign diagram here. So remember, anytime you have a sign diagram, you want to put your x-intercepts or your asymptotes. So here I can see that I have an x-intercept at -3. I have an x-intercept at -1. And I also have an x-intercept at a +4. So I'm going to pick a number in between all of these intervals here. Or, to be honest, I can just look at it and tell what's going on. So I see that my graph is above the x-axis here and above the x-axis here to here. I see that I'm below from here and here. So therefore, I can put my labels as follows. So in between -3 and -1, I'm negative. For higher, I'm negative. If I'm any x value that's less than -3, I'm above the x-axis, I'm positive. And then between -1 and 4, I'm also positive. All right. So for number 2, I want to do the same thing. So when I do that for number 2, I am going to look at my x-intercepts and my vertical asymptotes. So I'm going to draw my graphs here. So here I have a vertical asymptote. I have one at -3. So I'm going to put a -3 here. I also see that I have a x-intercept at a +1. And then I see that I have another vertical asymptote at negative 2, or excuse me, positive 2. So now that I have that, I'm going to look at when it's below and above. So I'm below here, I am below here, and I am going to be above here, and I'm going to be above here. So I just label accordingly. So I'm going to be negative here, negative here. I'm going to be above a positive here and here. All right. So now let's say if we have a function. So let's say if I have 2x minus 5 and then x plus 4. And of course that'll be y equals. So if I substitute this into y equals, because I want to graph the function, when I do that, I'm going to look at the graph. And when I look at the graph here, I can tell that my graph goes down and then it comes back up. It is quadratic. So I can see here that I have two x-intercepts. All right, so my x-intercepts can be found by pressing second trace. And then I'm going to go to 0. So I'm going to go to left side to the x-intercept on the left. I'm going to push enter on the left side, then go to the right side. It's in between, press enter again. So I see that my x-intercept is going to be a negative 4. And if I do the same thing for the one on the right, I will end up seeing that the x-intercept on the left side, press enter. On the right side, press enter. Enter again, I see that it's at 2.5. So since those are my x-intercepts, I just label negative 4, 2.5, and then I look at whether my answer is positive or negative. So I'm going to look at my number here. I'm going to pick negative 5 here. I'm going to pick 0 here, and I'm going to pick 3 here. So you can go back out and you can just substitute in. So you could say 2 times negative 5 minus 5 times negative 5 plus 4. And you will see that I get a positive 15, which means that this interval will be above. Or you can actually look at the table. You already put the function in into y equals, so look at the table. So I see that when x was negative 5, I got a positive number. So that's why I have a positive. Then I look at when x is 0, you see that the value of my function is negative. And then if I have x is equal to 3, I end up getting that I have a function y value of positive 7. So that's positive there. All right. So same thing for number 4. I need to put it in y equals, and I need to look at my x-intercepts or my vertical asymptotes. So I'm going to graph this one. And as I can see, this is another quadratic. And I see that it looks like it touches the x-axis just at this point up here on the top. So I'm going to press second trace, and I'm going to press 0. And I'm going to go to the left side of it and press enter. So I know it's somewhere up here. So I'm going to go to the left side and press enter. Then I'm going to go to the right side and press enter. Press enter again. And it tells me error, no sign change. That is perfectly fine. It only says that because normally x-intercept, it will end up seeing that the value is you trying to figure out where your graph goes from above the x-axis to below the x-axis or vice versa. So it's not seeing that it was once negative and positive or vice versa. So if we see that that's happening, we can also say, well, okay, we see that the x-intercept may be there, but let's see. We can also tell that this is a maximum. So I'm going to press second trace, and I'm going to press number 4 for maximum. I'm going to go to the left side of it and press enter. And then I'm going to go to the right side of it and then press enter again, press enter. As you can see here, it has here that I have negative 6.99999 repeated. And then it has negative 6.98 times 10 to the power of negative 13. So we already know that when we move our decimal to the left repeatedly, then 13 times is going to get very, 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 very close to zero. So we can basically confirm that the maximum is going to be a negative 70 by looking at the table. So I press second graph, and as you can see here, negative 70. So that tells you also that the x-intercept is going to be at negative 7 because that's the value of x when y is also 0. So we know the x-intercept is going to be equal to negative 7 here. So if we graph this, we graph negative 7 here. I want to pick a number in that range, so I'm going to pick negative 9 here, and I'm going to pick 4 here. So if I go to negative 9, I see that the value was negative, so my function is negative or below the x-axis here. And if I go to positive 4, which is a number that's greater than negative 7, I can see that it's also a negative value, which would make sense because based off of this graph here, I see that it's below the x-axis, then it touches the x-axis, which makes it 0, and then it goes back below the x-axis. So that's accurate. So last but not least, number 5, we have x minus 1 over 2x plus 1. So remember, we want to find our x-intercepts and our vertical asymptotes. So your x-intercepts is where your y value is 0. So remember, anytime we want y is equal to 0, we already know this function is, I can say this is equal to y. So if I want this to be equal to 0, I'm just saying where's my numerator going to be equal to 0 at. So if I want to find my x-intercept, I'm going to look at my numerator. So x minus 1, I want it to figure out what's going to make that 0. So that's going to be a positive 1. So I'm going to put a positive 1 on my graph. Next, for the vertical asymptote, that's the value in which my function is undefined, meaning that I will be dividing by 0. So your vertical asymptote is going to be what makes your denominator equal to 0 because you can't divide by 0. So that will be a negative 1/2 there. So I will plot that on a number line as well. So now that I have that, I can just go to the table and then I can see where my numbers will be. So a number that's smaller than negative 1/2, I'm going to pick negative 1. A number that's in between negative 1/2 and 1 is 0, and a number that's bigger than 1 is 2. So if I look here, when x is negative 1, the value of y is positive, so it's above the x-axis. If I pick 0, the value then goes to negative, it goes below the x-axis. And then if I pick an x value of 2, that means it's back positive here. So if I look at my graph, that's exactly what's happening. So from any x value all the way up until negative 1/2, it was above the x-axis, and then it jumped down and it was below the x-axis up until when x was equal to 1, and then it went back positive. All right. So if you have any questions on sign diagrams, please ask your teacher or let me know. Have a great day.